Have you ever looked at a beautiful stained glass window? Or maybe a shiny, colorful gemstone like a ruby or an emerald? The amazing colors you see often come from a special group of elements on the periodic table. We call them the transition elements, or transition metals. Honestly, they are truly the artists of the chemical world. These elements are located right in the middle block of the periodic table. Think of elements like iron, which makes our blood red, or copper, which can turn green like the Statue of Liberty. They have some very neat properties that make them different from other elements, and their ability to create a rainbow of colors is one of the coolest. So, what makes these elements so special? It's all about their electrons. Electrons are tiny particles that orbit the center or nucleus of an atom. In most elements, these electrons are arranged in very stable, predictable shells. But transition elements are a bit more flexible. They have electrons in what scientists call the d orbital. This special area allows the electrons to move around and absorb energy in unique ways. This isn't just a small detail, it's the fundamental reason behind their vibrant personalities. It's this electron behavior that sets the stage for all the colorful chemistry we are about to explore. It's a property that is both fascinating and incredibly useful in our world. Let's think about some examples you might know. Iron isn't just one color. In its pure, solid form, it's a grayish metal. But when it rusts, it turns a reddish-brown color. That's because the iron atoms are reacting with oxygen and changing their chemical state. Copper is another great example. A new penny is shiny and reddish-brown, but older copper statues and roofs often have a beautiful blue-green patina. These color changes are all because copper is a transition element. This ability to show different colors depending on what they are bonded to makes them the stars of many chemical reactions and artistic materials throughout history. This incredible property isn't just for show. The colors of transition elements tell us a story. They give chemists clues about what is happening inside a chemical reaction. By observing a color change, a scientist can understand that new chemical bonds have formed or that the element has changed its oxidation state, which is like its electrical charge. It's a visual signal that something amazing has happened on a microscopic level. So when we see these colors, we are literally watching chemistry happen right before our very eyes. It's a powerful tool and a beautiful phenomenon, all rolled into one. Science is cool. Now let's put on our safety goggles and step into the lab. We can see this colorful chemistry in action with a very simple and safe experiment. Imagine we have a few clear glass beakers lined up on a lab bench. Each beaker contains a clear, colorless liquid. For our experiment, one of these liquids is water, and another might be a solution of ammonia, which is a common household cleaner. Our goal is to see what happens when we add a transition element compound to these liquids. This is where the magic, or rather, the science, begins. The setup is simple, but the results are going to be spectacular. First, we take a small amount of a salt called copper sulfate. In its solid form, it's a beautiful blue crystal. When we dissolve it in a beaker of plain water, the water itself turns a lovely light blue color. This is our starting point. The blue color is our first clue. It tells us that the copper ions, that's copper atoms that have lost a couple of electrons, are now floating around in the water. The water molecules are surrounding the copper ions, creating something called a complex ion. This specific arrangement of water molecules around the copper is what produces that signature blue color we see. The real fun starts when we introduce a change. The result is a brand new color. We started with two clear liquids in a blue solution, and by mixing them, we created an entirely different, vibrant shade. That's the power of transition element chemistry. Learning about the colorful world of transition elements is more than just a fun lab experiment. It shows us a fundamental principle of how matter and energy interact. Understanding why things have color is a gateway to understanding quantum mechanics, the science of the super-small. The idea that electrons can only jump between specific energy levels is a core concept that explains how atoms work. So by watching a solution change from blue to darker blue, we are witnessing a quantum leap in action. It makes the invisible world of atoms and electrons visible and understandable. This knowledge is also incredibly important in the real world. Chemists and engineers use these color-changing properties all the time. For example, some chemical tests use color changes to detect the presence of certain metals in water, helping to ensure our drinking water is safe. In medicine, doctors can analyze the color of certain chemical tests on blood or urine to diagnose diseases. Artists and paint manufacturers must understand the chemistry of pigments, many of which are based on transition elements like cobalt for blue, chromium for green, and cadmium for yellow, to create stable and brilliant colors for their work. Furthermore, studying these colors sparks curiosity and makes science more engaging. It's one thing to read about chemical formulas in a textbook, but it's another thing entirely to see a clear liquid turn a vibrant color with your own eyes. These wow moments are what inspire future scientists, innovators, and thinkers. They make science tangible and exciting, proving that it's not just a collection of facts, but a dynamic and creative process of discovery. So, the next time you see a colorful firework, a bright paint color, or even the subtle colors in a piece of pottery, take a moment to consider the following. You might be looking at transition elements in action.